Today we're going to be studying mathematics.
And emerges from the second mirror.
These words sound
Be your teacher for today. Hello students, I'm so happy to see you in our class for today. I hope you did well in the homework given to you. Today we are going to consider another topic, which is factors and multiples. And it's going to be fun, okay? Now, let's start with factors. Factors are numbers What does that mean? Think about someone asks you to find the factors of 16. Example, find the factors of 16. What does that mean? It means you look for numbers that can divide 16 without remainder. So what are we going to do? 16. You look for the smallest number that can divide 16 without remainder. And what is that number? Can you please help me out? Okay, 2. How many 2 can we find in 16? You think of number that you can multiply by 2 that will give you 16. And that is 8. You use 2 again. How many 2 can we get in 8? We have 4. Okay. How many 2 can we get in 4? 2. 2 in 2, 1. Now, factors of 16 are 1, 2. You are not going to repeat these numbers, and that is what we call factors. Without repeating a number, repeating a number. We have 4, we have 8, and we have 16. 1 can divide 16, it will give us 16 without remainder. 2 can divide 16, we have 8. 4 can divide 16, we have 4. 8 can divide 16, we have 2. And 16 can divide 16, we have 1. So let's go to another example. Now we are looking at prime factors. Prime factors. Okay. We want to find prime factors of numbers. Example, find the prime factors of 64. What are we going to do? Let's solve it together. 64. You think of number that can divide 64 without remainder. That is 2. 2 in 6 will give us 3. 2 in 4 will give us 2. You use 2 again. How many 2 can we get in 3? 1. Remainder 1. Put that 1 at the front of 2. We have 12. So 2 in 12 will give us 6. 2 in 16 will give us 8. 2 in 8 will give us 4. 2 in 4 will give us 2. 2 in 2 will give us 1. Okay? So, prime factor of 64 is what? Is 2. Okay? Now, let's look at another example. Okay, let's see how we can find common factors of numbers. Look at this example. Find the common factors of 16 and 18. What are we going to do? Okay, let's solve it together. We have 16 and we have 18. How many 2 can we get in 16? 8. 2 in 18, 9. Okay? Now, there is no number that can divide 8 and 9 without remainder. If we should use 2, 2 can divide in 8, but 2 cannot divide 9. Are you following me? So, our common factor of 16 and 18 is what? Is 2. I hope you get it right. Now, let's see another example. So, our next example is expressing the prime factors of 108 in index form. How can we solve this? Let's solve it together. We have 108. How many 2 can we get in 10? 5. How many 2 can we get in 8? 4. How many 2 can we get in 5? Is 2. Remainder 1. That one, put it at the front of this 4. You have 14. How many 2 can we get in 14? 7. Okay? Can we still use 2 to divide 27 without remainder? No. So what are we going to use? 3. How many 3 can we get in 27? You think of number you can multiply by 27, by 3, that will give you 27. And what is that number? 9. Okay? How many 3 can we get in 9? Is 3. How many 3 can we get in 3? Is 1. So we have 2 times 2 times 3 times 3 times 3. Bring this together. Bring this together. Now, in index form is referring to power. So, in index form, so this is prime factors. Index form will give us 2 square times 3 square times 3. So this will be our answer. Now, we want to look at how to find highest common factor and lowest common multiple. We want to look at highest common factor. We call it HCF. Okay? Let me give you an example. Example. Find the HCF of 20, 18, and 16. Let's solve this together. Are you good to go? Okay. Now, we have different methods used in solving HCF. So, I'm going to give you my method, and I believe you also have your method, right? So you can use any method as long as you are on, we are on the same track. Okay, 20, 18, and 16. We think of number we can use to divide 20, the same number divide 18, the same number divide 16 without remainder. So who can guess that number? Okay, we can use 2. 2. How many 2 can we get in 2? 1. Bring down the 0. How many 2 can we get in 18? It's 9. How many 2 can we get in 16? Is what? Is 8. Now, is there any number we can use to divide 10, 9, and 8 without remainder? No. If we use 2, 2 can divide 10, we get 5. 2 cannot divide 9. We are going to have remainder. But 2 can divide 8. So, our HCF will be equals to what? 2. You can see that this is very simple. if you can only listen in this class and follow the way we are doing it together. I trust you are following me. Now, you might say that this is very simple. Now, let me surprise you with this question on HCF. Now, we want to find the HCF of 8x squared y cubed, 16x y squared, and 10x squared y squared. Don't be afraid. It's very simple. Let's solve it together. Okay? Pick this. We have 8x squared y cubed equals to 8. 2 in 8 will give us 4. 2 in 4 will give us 2. 2 in 2 will give us 1. Pick this. 2 times 2, 4. 4 times 2, 8. You have 2 times 2 times 2. X squared means x in 2 places. X. Y cubed means y in 3 places. Okay, pick this. You have 16 xy squared. You can do this also. 16. 2 in 16, 8. 2 in 8, 4. 2 in 4, 2. 2 in 2, 1. So you have 1, 2, 3, 4. 2 times 2 times 2 times 2. X times x, y squared times y times y. Pick the last one. You have 10x squared y squared. This will give us 10. You can do that one. 2 times 10 will give us 2 times 5 will give us 10. 2 times 5 times x squared, x times x times y squared, y times y. Okay, now we are finding the highest common factor. That means the factor that is common to this, this, and this. Let's start bringing. 2 is common. There's 2 here, there's 2 here. There's no 2 here. There's 2 here, there's 2 here. There's no 2 here. There is x here. Okay. There is another x here. Okay. There is x here. Okay. Do we have any other x here? No. That means this cannot go. X is not common again. But we have y. Y is here. Y is here. Another y is here. Okay. Do we have any other y common to this, this, and this? Yes. You can see the last one. Y is here. Another y is here. And another y is here. Okay. So our HCF will be 2 times x times y times y. So this will give us 2x. Y times y will give us y squared. So I believe this might look so strange to you, but if you go over it, you will discover that it's very simple. Now, before we round up this class, let's see LCM. Finding LCM is a little bit different from finding HCF. I've been in the class and I always encourage my students to apply their knowledge in everything we are doing in the class. So it's not only me that I'll be solving questions and my students will be watching me. I want you to do something over there also. So if you have any method you can use to find LCM, as long as you get your answer, you are correct. So in this video, I'll be using this method, and that doesn't mean that you also must use this method. If you know any other method you can use, you are good to go. So let me use my method and find this example. Okay, example. Okay, let's find the LCM of 15, 20, and 10. How can we do this? Let's do it. This is my method, 15, 20, and 10. So, you look for a number that can divide 15, that can divide 20, and that can also divide 10. Or I can use 5. 5. Yes, thank you very much. 5 in 15 will give us 3. 5 in 20 will give us 4. 5 in 10 will give us 2. Now, let me remind you, if you are finding HCF, your answer will stop here. But now we are doing LCM. We can still continue. How? 2. 2 cannot divide 3. You bring down the 3. 2 in 4, 2. 2 in 2, 1. You can use 2 again. 2 cannot divide 3. Bring it down again. 2 in 2, 1. 2 in 1. 2 cannot divide 1. You bring it down. You use 3. 3 in 3, 1. 3 cannot go in 1. You bring it down. 3 cannot go in 1. You bring it down. So once you get 1, 1, 1, that's where you stop for LCM. Now, our LCM will give us 5 times 2 times 2 times 3. 5 times 2, 10. 10 times 2, 10 times 2 will give us 20, and 20 times 3 will give us 60. So our LCM is 60. I believe you are following this class. Now, before we leave this class, I want to give you another strong question on LCM, because I know that some of you might look at this question. It's very simple. Let me give you something. Find the LCM of 9x squared y squared, 6x y squared, and 12x squared y squared. How can we solve this? It looks so strange, but we can still do it, right? That's why we are mathematicians. I believe you are a mathematician, right? Okay, now pick this 9x squared y squared. Pick this 6x y squared, and pick this 12x squared y squared. Okay, starting from here, you come here 9. 3 can divide 9, 3. 3 and 3, 1. This will give us 3 times 3, which is 9. X squared means x times x. Y squared means y times y. Okay? I hope I'm not too fast. Okay, you are following me right. Okay. Now pick 6. 6 is here. 2 and 6, 3. 3 and 3 will give us 1. We have 2 times 3 times y squared means y times y. Okay, pick 12. 12. 2 in 12, 6. 2 in 6, 3. 3 in 3, 1. 2 times 2, 4. 4 times 3, 12. 2 times 2 times 3. X squared means x times x. Y squared means y times y. We have 12x squared y squared, which will give us 2 times 2 times 3 times x times y times y. 6x squared, 6xy squared will give us 2 times 3 times x times y times y. And we have this also. Now, let's pick something out from here. You can see that 3 is common here, here, here. We have 3 here, we have 2 here, we have 2 here. We don't have 2 here. It's not common. Okay? Let's pick x. X is common here, is common here, and is common here. Okay? Do we still have another s that is common? No. What of y? Y is common here, here, okay, and we also have y here, okay. Another y is common, y, and y. Don't get confused. Just try to and trace it. Okay? Our SCM will be, pick these 3, multiply it by these 2, because they stand alone. Multiply it by these 2. Multiply it by these 2. These are common, right? Pick one out of it. By 3, x is common. By x, there is another x here, times x. There is another x here, times x. Y is common, times y. Y is common, times y. You know, when you are doing this at home, you have to be very careful. Okay, now let's let's multiply. 3 times 2 will give us 6. 6 times 2 will give us 12. 12 times 2 will give us 24. 24 times 3, this one will give us 12. 2 carry 1 will give us 72. Okay, so we have 72 times x times x times x will give us s cubed. Y times y will give us y squared. So it will give us 72 s cubed y squared. This looks so strange, but I believe that you are following the class, and always have positive mind when we are solving mathematics. It is not too hard. You can still do it. Now, before we leave this class, I want to give you work to do for me at home. And I believe that you are so eager to see the homework for today. Am I right? You are going to do this for me at home. Find the prime factors of 144. Find the product of prime factors of 120 in index form. Find the LCM of 120, 60, and 18. Find the ACF of 16x squared y cubed, 12xy cubed, and 10x squared y cubed. I hope you're enjoying this class, and I believe that next class is going to be more interesting than this, because I'm preparing for you, and I'll be very happy to see you next class. Thank you very much. See you next class. Au revoir.